name is Uhley. I work at Adobe on Flash Player Security, so I'm the platform security strategist there. I think most of you remember I yesterday, so that's pretty fun. That's all I'm going to do. So what I'm going to talk about today is some of the changes that are going on in the browser over the last year and a half with regards to cross-domain technologies. In the past, it used to be that Flash Player was the only one where you could do cross-domain requests and be able to get responses back. Now the web browsers have made several advancements, and you're actually starting to see them show up in HTML5 and JavaScript. So I'm going to talk about a few of those, talk about some of the risks that people need to watch for, and then wrap things up. So you're all familiar with the same origin policy. Basically, a request from website A cannot see the response that comes back from website B. You're allowed to do cross-domain gets and posts, but basically data has to stay within the fully qualified domain of where the page is hosted. So if you make a get or a post, you can go ahead and you can make that get and post, but you would never be able to receive the response. So for instance, cross-site request forgery attacks, you're usually flying blind, just issuing a bunch of get requests in a row, but you're not quite positive whether they're working or not because you can't actually see the response. And for the most part, that was good. It meant that evil.org didn't steal the cookies from example.org. However, it was really limiting for developers because they didn't want to design monolithic architectures with all the concepts on the same domain. Going to switch mics? Okay. They didn't want to design monolithic architectures that were all hosted on, where everything was hosted on one fully qualified domain name. They needed to be able to use CDNs, they needed to be able to separate out their services, so they needed to be able to separate out that content. And in the past, what they did is they found lots of workarounds to be able to share the information across domain. And the workarounds were basically just sort of edge cases that in some instances the browsers didn't intend to support, but the developers found it and they started using it anyway. So you've seen places with JSON requests where they would do cross-domain sharing of information via JSON requests and using eval, altering document.domain. So if you go and change the domain within JavaScript to be the parent domain, so if you change www.example.org to example.org, you can actually get the browser to allow JavaScript requests within the parent domain. A lot of websites were using that trick. Some people were passing information via fragment identifiers because you're able to read the fragment identifier off the URL across domain, even though you couldn't see the full URL. In some cases, they would just do multiple iframes and have A create a child frame that pointed to B, and then B would create a child frame that pointed to A, which would essentially pass the information back into A. So there were all these little tricks and workarounds that they did. Some of them were kind of kludgy, and they're hard to find. It's sometimes hard if you're doing a website audit and you're trying to figure out where they're sharing information across domain. Finding these little tricks in their code, it requires you to go through and read line by line everything they're doing and to actually see it. So the web browsers decided that it was better to have a formal approach to doing this than having people do all these little tricks and using edge cases. By adding these advancements into the web browser, one, it makes it easier for you guys to audit. There are certain things that you can specifically look for. And also, you can train people around supported methods. It's really hard to train people around unsupported methods or undocumented methods. Those undocumented methods tend not to work cross-browser. So there are just a lot of issues with trying to do these sort of weird approaches to things. So one of the things that was introduced was access control, and that was introduced by the W3C. And what it does is it allows you to do cross-domain XHR requests. Right now it's supported in Safari and Firefox. When I tried it last night, I wasn't able to get to work in IE, and I didn't get a chance to try Chrome. But it allows you to send cross-domain requests, and the responses are per URI. So if you're familiar with Flash's cross-domain model, we allow you to do things down to the directory level. With W3C access control, everything's sent back in headers. So you can actually set the permissions on a page-by-page basis based on the headers that get returned by that particular page. And if you want to see demos of it, I provide a URL where someone has demos of all the different access control requests. So the way it starts is you're allowed to do a cross-domain GET request straight out. You can create an XHR request that does GET off to some domain. However, if you're going to do a complicated XHR request, for instance, one that involves post or one that involves arbitrary headers, what you end up doing first is you end up doing what's known as a pre-flight request. So one of the challenges with sending headers is that if I go and I send, I can't send the headers first and then wait for the response headers to find out whether or not I was allowed to actually send them. I have to first ask, am I allowed to send headers? Then once I know whether I'm allowed to send headers, then I can let the XHR request go through and send those headers to the domain. So I have to do this pre-flight first that says, am I allowed to send headers? And then once I get that answer back, I can actually let the request go forward. So the way it looks is there's three different headers which can be sent across. One is the origin header. The origin header is very similar to the refer variable, except it only tells you what the domain is. So this is a new header which gets sent across. There's the access control request method, which specifies which HTTP request is allowed, whether it's GET or POST, and whether it allows posts. And then there's access control request headers, which says these are the headers that the content is asking to serve. Am I allowed to actually send you these headers? And then as far as responses, there's 5 different headers which can come back as part of the response. Access control allow origin tells the browser that the domains that you're going to allow this information to be shared with. There's a max age which says how long this rule is in effect for. So these rules can expire in case someone leaves their browser on for 2 months. Allow credentials. Identifies which headers are allowed to be shared across domains, the methods, and headers in general. So what this ends up looking like is in the code, it still looks like an XML HTTP request. It's the only way you can tell it's cross-domain just by looking at the JavaScript is by looking at the URL it's going to and realizing that it's not, that the HTML source that you're looking on doesn't match that domain. So you generate a new XML HTTP request, you do client.open, where you send a custom header called custom. So rather than doing GET, this code does a custom request. And then you set up an event listener to receive the response, and you click, and you go ahead and send the request over. Since this particular request, I'm using a custom method, I'm not using GET or POST, or I'm not using GET, I have to first do a pre-flight request. It's going to send over the origin of where my code was hosted, and it's going to say, is this code allowed to send a custom method? And then the response is going to come back. You'll get your normal HTTP 200 responses back, but also in there you'll have access control allow origin. This is the domains I allow. This is how long it's allowed for, and an instruction saying back, yes, I do actually allow custom headers. And then once it's done the pre-flight, then it can go ahead and do the actual XML HTTP request where it does the custom, sends over the origin, and then you get back a response with the access control allow origin header and the body of the data. So at that point, the XHR request would have access to hello world, which was the body of the data that came back. There are a couple other benefits to this. People are trying to expand the origin header for other uses, sort of as a less privacy invasive refer value. So rather than sending, in some cases, they don't want to send the entire HTTP refer because there may be stuff in the string that shouldn't be shared across domains. but the W3C has been discussing, well, maybe we can just share the domain itself. And then this can help with things like cross-site request forgery because you can see where the request is coming from. You can take a look at the origin header and see, oh, hey, I'm not supposed to receive posts from that domain, and drop the request. Actually, I think the last line is because I shouldn't be there. I forgot to actually take that out. So ignore the last bullet on this. The W3C access controls were basically built on top of XHR. But if you see XHR2, or people talk about XHR level 2, that talks about XHR that's able to support this functionality. Microsoft for IE had a different approach. They introduced a control called XDR. And XDR is still a way of doing an XML HTTP request, but for various reasons, Microsoft felt that having a new API for it was better than building on top of an existing API because you didn't have to worry about backwards breakage. You can start from a clean design. And it would also, if you're grepping through the code to try to figure out, does this HTML page do any cross-domain requests? If you have a specific API dedicated to that, it's much easier to identify it in the code rather than looking at every XHR and checking the URLs for them. So they introduced in IE 8 beta 1. They integrated into the internet zones philosophy that they use for most web content. The protocols must match. One of the things that differs in their model is they don't send cookies. There's a matter of debate between the people who do cross-domain models about whether or not you should send cookies with a cross-domain request. Some camps believe that you should go ahead and add cookies to the cross-domain request because that allows you to do authentication and authorization checks. In other scenarios, they believe that cookies shouldn't be sent with the cross-domain request because that increases the amount of risk that they might be echoed back in the response, and why send them if you can avoid it. Again, it's per URI, and it uses a header to inform the browser whether or not it's allowed to share the response data. So they originally had their own header, and then in IE 8 beta 2, they transferred over to using the access control allow origin header from the W3C just to make it a little more consistent, even though the JavaScript calls are slightly different. So with XDR, what you would see in JavaScript is new X domain request, XDR open, you can do a post, and you would send that information back, and then you would have a response or event handler to get to the response when it comes back, and you could actually show the data which came back. Another way of sending cross-domain requests that's been introduced within the browsers is post message. This is supported both in IE 8 and Firefox. And basically what post message does is it allows you to share data in between frames. So if you have a parent frame and the child iframe, what you're able to do is register events off of between the two frames so that they can pass messages back and forth. So I believe it's now officially in the WebKit builds. It says WebKit Nightlies, but I think it's officially in WebKit now. And the security is controlled by placing a to address in the message. So the way the API works is the first value is what you want to send, and the second message is the domain you want to send it to. The domain you want to send it to is an optional parameter for that. And this control, unlike the XHR stuff, is per domain. So the way the code looks is you'd have, let's say, a form where you collect some information. You want to be able to post that to the child iframe. The bold section down here where it says Windows post message, all I'm doing is I'm getting the element for the message value, and I'm sending it to the iframe. So it's a very simple to-value call. It's just post message, the value you want to send, and then followed by the domain you want to send it to. On the receiving side, you add an event listener on your window. In IE, it's window.attach event. And you catch the event as it comes across the frame boundary. Now,